Evan Spiegel is in Long Beach, smiling through a pair of black glasses that look almost normal until you notice the hardware in the temples. These are Snap's new specs. They cost $21.95, and Snap is pitching them as a computer you wear on your face.
The big difference is that specs are standalone augmented reality glasses. No phone tether, no belt pack, no headset shell. The frame carries cameras, depth sensing, waveguides, electrochromic lenses, and 2 Snapdragon processors. One for seeing the world, one for running the lenses that appear in it. The demos explain the bet better than the spec sheet. Directions sit on the sidewalk. A restaurant cart floats in the space ahead of you. Ask where to add coolant, and the glasses point to the part under the hood. Snap is trying to move AI help out of a chat box and into the scene you are already looking at. For AR, the hard part is making the digital layer feel like it belongs in the room. Snap says specs have 7 millisecond motion-to-photon latency, a dual waveguide display, 16 million colors, and a 51-degree field of view. That field of view is the important number. It gives developers more space to build something that feels like an app, not a tiny floating notification. The platform story is why this launch is bigger than a gadget demo. Snap says more than 450,000 developers have built with Lens Studio, and it is adding tools to bring real code and existing projects into specs, a native development kit, Unity migration help, and agentic workflows for Claude Code, Codex, and Cursor. The question is whether those tools can turn clever demos into reasons people keep wearing the glasses. Then the trade-offs hit fast. 4 hours of mixed-use battery, a case that gives more sessions, not continuous all-day wear, a frame around 132 grams, depending on size, and a price higher than many laptops. There is also the social problem. Specs have cameras and microphones facing the world around the wearer. Snap points to a recording LED, on-device processing, and privacy controls. Those are real design signals. They do not erase the older memory of camera glasses, or the simple fact that this is still a visible computer on your face. So specs are both impressive and unresolved. Snap has made a serious standalone AR platform with visual AI, developer tools, and real spatial demos. It has also made a $2,100 face computer with short battery sessions and a lot to prove in public. The hardware is finally close enough to make the question real. Can developers build something useful enough that people actually want to wear it?